So this week we're going to look at revising Pythagoras' theorem. So I'd like you to just stop and think about when we use Pythagoras, what the rule is, and just see what you can remember before moving on to the next slide. So Pythagoras' theorem can be used to work out the length of a side in a right-angled triangle. And it involves the two shorter sides here, A, next to the right angle. So the two sides perpendicular to each other we call A and B. And C is the side opposite the right angle. And C is the side, and this side here opposite the right angle is called the hypotenuse. Hypotenuse. And this is the longest side of a right angled triangle, and it's also the side opposite the right angle. So just worth remembering. So we always label the shorter sides A and B, and the hypotenuse is always C. Now Pythagoras' theorem states that the square of the hypotenuse, so in this case C squared, equals the square of the sum of the two sides, so equals A squared plus B squared. So C squared equals A squared plus B squared. And the first thing you should always do is label your triangle ABC and then write out the rule. Okay, and you do that for any question you do involving a right angle triangle. We'll just work through a couple of examples. So here we've got example 6. It says calculate side A. Now the first thing I would do is I'd look at my right angled triangle and I would label it A, B and C. Now we said A and B were the two sides perpendicular to each other, the shorter sides, and the longest side, the hypotenuse, is C. So I've labelled my sides. Right, the next thing we need to do is write out the rule. So we're going to write out the rule. I'll just write the little rules there. So the rule says that C squared equals A squared plus B squared. That's Pythagoras' rule. Once I've done that, I would make the substitutions. So C squared in this question here, C squared is actually A, so that becomes A squared. A is 5 centimetres, so that becomes 5 squared. And B is 3, so it becomes 3 squared. I would then work those out, so that becomes 25 plus 9. Adding those together means that A squared equals 34, so therefore A equals the square root of 34. And the square root of 34 is 5.83. Now the question hasn't specified whether it's 1 decimal place, 2 decimal places, so I'll give my answer to 3 significant figures, and there we go. So follow the basic rules, label your sides, write out the rule, make your substitutions, and then calculate. So working through the set steps, the first step, label the sides A, B and C. So the two shorter sides are A and B, and the hypotenuse is C. The next thing, write out the rule. Well, I know that C squared equals A squared plus B squared. Third step, make the substitutions. Well, C is 11, so that becomes 11 squared. A is 8, so it becomes 8 squared. And B is our unknown variable, B squared. I then need to calculate. Rearranging, this gives me 11 squared minus 8 squared equals B squared. 121 minus 64 equals b squared, and therefore we can say b equals the square root of 57. So therefore b equals 7.55 centimetres to 3 significant figures. Please pause the video now and have a go at answering the question, and then check the solution afterwards. So we have a trapezium and we've been asked to work out the value of k. Well, if I split my shape up, so I'll split the shape up into a rectangle and a triangle. So I know that in this triangle, the height of the triangle is 20 and the hypotenuse of the triangle is 22. So I'm going to draw that out separately. I've got a right angle triangle, 20 and 22. Now I'm going to label my sides of the right angle triangle A, B and C. So C is the hypotenuse. I'll call this A and this B. The next thing we need to do is write out the rule. So we know that c squared equals a squared plus b squared. Then I'm going to make my substitutions. So that will give me 22 squared equals 20 squared plus b squared. So therefore b squared will equal 22 squared minus 20 squared. And b will equal the square root of this. So the square root of 22 squared minus 20 squared, which to 3 significant figures is 9.17 centimetres. So in this diagram here, I know that that is 9.17 centimetres. So therefore, I can work out what k is. I can say, okay, well k, the whole length here is 30 centimetres. K will equal 30 minus 9.17, which is 20.8 centimetres. So here we have another problem. Again, pause the video and have a go at it and then check your answer afterwards. Well, in this question, we've told that ABCD is a rectangle and Sunita calculates the length of AC, so AC being the diagonal. She calculates that length as 8 squared minus 6 squared equals AC squared. She follows that through, but she has done it wrong. So we can see here in our triangle that this hypotenuse actually is C. So what she should have done is she should have added the two values together. So in fact, AC squared is actually equal to AB squared plus BC squared using Pythagoras' rule. So to then go on and calculate this, well, we can say that, okay, so C squared, which is AB squared, so our AC squared equals AB squared plus BC squared. Making our substitutions would give us 6 squared plus 8 squared. So AC squared equals 36 plus 64, which gives 100. So therefore AC is square root of 100, which is 10 centimetres. A nice straightforward one for you there. In this example, we're told that triangle ABC has a perimeter of 20 centimetres. We're told that AB is 7 centimetres, so I will write that in, and BC is 4 centimetres. By calculation, deduce whether the ABC is a right angled triangle. Now, if it was a right angled triangle, then we would know, so if it was a right angled triangle, then AC squared would equal AB squared plus BC squared. So AC squared, so that would give us 7 squared plus 4 squared, which is 49 plus 16 which is 65. So therefore AC equals the square root of 65, which is 8.06. if right angle. So if it was a right angle triangle, that's how long it should be. However, we know perimeter is equal to 20. So we're told that. Therefore, we know that AC is actually equal to 20 minus 7 plus 4, the length of the other two sides, which is 20 minus 11, which equals 9. So therefore, triangle ABC is not right angled. And there we go. Make sure you give your proof clearly, write everything clearly, don't just rely on the calculator. Very often in the GCSE you'll get two-stage questions, so you have to work out one length to help you work out another length in the second triangle. So here we need to work out what x is, but x has two unknowns in that triangle. So we can work out what y is in this triangle here. I'm going to call that y centimetres. So in triangle ABD, so in triangle ABD, if I call that C, and these sides are A and B, then I can say that C squared equals A squared plus B squared. I've labelled my triangle, written out the rule. Now I make the substitutions. I say 10 squared equals 5 squared plus y squared. So therefore y will equal the square root of 10 squared minus 5 squared, just rearranging the equation. So y will equal the square root of 75, which is 8.66. So I've now worked out that side there. So here, this side is 8.66. So now we're going to look in triangle BCD. So in triangle BCD, here's my C, this now becomes my A, and here we have our side B. So C squared equals A squared plus B squared. I've written out the rule, now I make the substitution. So x squared equals 4 squared plus 8.66 squared. Now we know what that is, don't we? We know that's going to be 75 because we square rooted 75 to get to 8.66. So x squared equals 16 plus 75. So therefore x will equal the square root of that, which is the square root of 91, to give us 9.54 centimetres to 3 significant figures. But it does actually say to do decimal places, so that's fine. Good. So very often in these sort of questions, nice question here is probably more, it comes towards the end of the paper, so it's a slightly more challenging sort of question, but one you should be able to do. So we've got a right angled triangle and we've been asked to write 2C in terms of A and B. So I'm going to look at my triangle A. So in triangle A, if I look at it, I know the rule connecting the sides. I know that C squared equals A squared plus B squared. Fine. Okay, so now I'm going to go to my triangle B here, and also using Pythagoras' rule, I can say okay, so in triangle B, square of the hypotenuse, so that's C plus 1, the square of that, so all squared, equals the sum of the squares of the other two sides, so it becomes A plus 1 squared, plus, that's not my A, that's not my B here, so plus B plus 1 squared. Now the sensible thing here would be to, well, let's see what happens. So I'm going to expand each of the brackets using the FOIL method. So that would give me, don't forget, this means C plus 1 times C plus 1. This here means A plus 1 times A plus 1. And this term here is B plus 1 times B plus 1. Don't forget, you need to write out the brackets in full. So that would give me C squared plus 2C plus 1 equals A squared plus 2A plus 1 plus B squared plus 2B plus 1. Okay, now we just want it in terms, we want 2C in terms of A and B. So I don't need C squared, but here I know that C squared equals A squared plus B squared. So here I can say, okay, that's A squared plus B squared. Instead of C squared, I've written A squared plus B squared. Then I've got 2C plus 1 equals A squared plus 2A plus B squared plus 2B, and I've added 1 plus 1 to give me plus 2. Right, now I just want it in terms of 2C, so I need to rearrange the formula now to leave me with just 2C. So that will give me A squared plus 2A plus B squared plus 2B plus 2, and then I've rearranged, I've taken, what we've done is we've taken this here and the plus 1 over to the other side, so we've rearranged that equation, and that will give me minus A squared minus B squared minus 1. Simplifying the right hand side, well, A squared minus A squared, then I've got B squared minus B squared, so they go. So that's going to leave me with 2A plus 2B, and then 2 take away 1 is plus 1. There we go, all done. So here's another question. You can pause the video now, work through the question, and then carry on and see whether, listening to the video to see whether or not you are correct. So here we've got ABC. We're told it's a right angled triangle and all the measurements are in centimetres. AB here equals x, BC is x plus 2, and AC equals x plus 4. And we're to use the information to form a quadratic equation in the form x squared plus ax plus b equals 0, where a and b are constants we need to find. Well, we've got right angled triangle, so I'm going to label the two shorter sides perpendicular to each other, A and B, and this side is C. So writing out Pythagoras gives me C squared equals A squared plus b squared. Then we're going to make the substitutions. That's x plus 4 all squared equals a squared, so x squared plus x plus 2 all squared. Not forgetting that x plus 4 all squared means x plus 4 times x plus 4. And x plus 2 all squared means x plus 2 times x plus 2. Using FOIL again, you should be good at FOIL by now. Multiplying the two first terms will give me x squared, 8x plus 16. And on the right hand side I'll have x squared plus x squared plus 4x plus 4. Right, so we need to rearrange this now. So I'm going to simplify the right hand side first. So we'll have x squared plus 8x plus 16 equals 2x squared plus 4x plus 4. Now the right hand side has the largest x squared, so I'm going to move everything from the left hand side to the right hand side. So I'm going to subtract x squared from both sides. That leaves me with x squared. Then I'm going to subtract 8x from both sides, so I'll have minus 4x. Then I'm going to subtract 16 from both sides, so that will leave me with minus 12. And there we go, we've written our quadratic in the form of x squared plus ax plus b. So therefore, my a, the coefficient of x, the number in front of the x is minus 4, so a equals minus 4. And the coefficient, the constant b, there's a number on its own there, the constant here, which is minus 12. So a equals minus 4 and b equals minus 12. I hope that gives you a flavour of the sort of questions that you could get asked in Pythagoras. So don't forget, label the sides A, B, C, write out the rules, make the substitutions into the formula, and then rearrange your formula using the rules you've learnt. And that's it.